Hello, this is Ray Enke from James Madison University, and today I'm going to show you a quick little video overview of how to set up the FastQC application in CyVerse Discovery Environment. So these images here are from a recent paper that my research lab published in Scientific Data, RNA sequencing analysis of the human retina and associated ocular tissues. Here are three of my really great former undergraduate students, Scott, Calvin, and Penny, who helped with the characterization of this study. And these images are showing the human donor tissue, where we dissected human donor eyes, and we dissected out the central macula, which is a cone-rich tissue, and the peripheral retina, which is a rod-rich tissue. And then panel D here is showing the experimental workflow that we used for mRNA-seq analysis of these tissues. Okay, so in class, in my genomics class, we typically talk about the overview of sort of a generic bulk RNA-seq transcriptome analysis, and where we always start is with the QC of the raw sequencing reads that come out of the sequencer. And this is important not just for RNA-seq experiments, but really for any sequencing experiment, whether it's a genome sequencing, RNA-seq, ChIP-seq, metagenomics, etc. You always want to check the quality of the reads to make sure that they are high quality. And typically this program called FastQC is sort of the one that is most commonly used. It's developed by the Braberham Bioinformatics Institute. And what this application does is you import your your .fastq files into FastQC, and you get sort of a 12-point check to check the quality of your files for a bunch of different metrics. I'll say there's an excellent video tutorial by the makers of this program that I would highly recommend. So here I'm just going to give a quick overview of how to set up this application using the CyVerse Discovery Environment, which is an app that we use frequently in my undergraduate classes as well as my undergraduate research program. So I'm going to go over here to CyVerse Discovery Environment. So here's the CyVerse DE homepage. Over here on the left, we have all these panels. Home, here's all my data, here's all my apps, and here's all my analyses. So what I'm first going to do is I'm going to go to the data pane, and I'm going to talk a little bit about sort of file architecture. So you can see I have a lot of different files here. I have this file right here, which is where all of my FastQ files are stored. And then right underneath it, I created a new folder. It's called FastQC-MultiQC. So remember, first of all, that you cannot have any spaces or special characters in CyVerse. And what I have is this FastQC MultiQC folder is where I'm going to output all of my FastQC and MultiQC jobs. So I'm just going to go in there, and you can see that I have some subfolders split off for MultiQC analysis, which I'll talk about later. I've also created this demo retina FastQC folder. So this is the specific folder where I'm going to dump all of my FastQC analysis for this demo that I'm doing now. So I'll go in here now, and you can see that there are no files in here. That's because we haven't yet done the job. So next, we'll go down here to the apps panel, and this is where you can either use this search bar up here to search for your apps. I'll just type in FastQC, although I'll also recommend that if you have apps that you're using over and over, to favorite them. And you can see that I have FastQC here as one of my favorite apps. So we'll be using this FastQC 0.11.5 multi-file. So I'm going to click into that, and we have a few pages of settings for the app. So the step one analysis info is where we're picking a name for our analysis as well as an output folder. So for the name, what I usually recommend is keep the FastQC portion, but delete out the rest of that. Put an underscore there, and then just use something that you will recognize. So I'm going to put retina underscore demo. And again, I would recommend keeping the application name, just so you know what application you're running, an underscore, and then some kind of descriptor that you'll know exactly what it is. The second thing we're specifying is the output folder. So this defaults to your analyses tab, which I'm not really a fan of. I like to have all of my output files that I'm going to use in my data tab. So rather than keeping this default, I'm going to go over here and I'm going to browse for a new location. And what I'm going to do is I'm going to select that demo retina FastQC folder that I specifically created for this project. So I'm selecting that folder. There's nothing in here now. I'll now go select this current folder, and this is specifying where I want these output files to be dumped after they're done. Then I'll click Next. Step 2 is asking you, okay, well, which FastQ files would you like to analyze with FastQC? So I'm going to hit the Browse button. I'm going to go back to my FastQ files folder, and here I have all of my different FastQ files in different folders split out by different projects. So I'm going to choose this folder, which just has some macula and retina folder files, and I will just select all of them. There's a bunch of FastQ files in here. They all have this .fastq.gz extension. That's a compressed FastQ file. So remember, FastQC, the software, the thing it does is it analyzes FastQ files and it checks their data quality. So it checks the quality of the data. You will not be able to run that program unless you're inputting .fastq files or .fastq.gz files. So once I've selected those, I'm going to hit OK. And now I can see that all of those files have now been entered here into my app input pane. I'm going to hit Next. Step 3 is optional advanced settings. So what I would recommend is just leaving those all as default, hitting Next. And then step 4 is the launch or save. And so this just kind of gives you an overview of what files you have in there. You can save it if you want, but this is where you would hit launch, and that will output you to your analyses tab, which will think for a minute, and then it'll show that it is running this FastQC demo retina that I started at this time, and its status is it's currently running. Up here, you'll get notifications. So my notifications up here is that you'll get a notification when it starts running. I will get another notification when that job is finished. And depending on how many files you input, depending on the size of those files, this could take 15 minutes to a couple hours. So you do have to be patient. And if you're doing this in a classroom setting, you do have to allow for the time. So what I'll do is I will scroll down here in my analyses tab, and I'll look for another FastQC job that I ran so we can look at some outputs. So here's a FastQC job that I ran, looks like a couple months ago. I'm going to go over here to this folder, which will show me that output folder. So this will give us a chance to look at the outputs of FastQC, even though these are different files because my app is still running that I just said. But this is what your output folder will look like when your job is finished. You'll have a logs folder that will tell you sort of the specifics and the parameters of your job. If you had an error, there'll be an error log in here. And then what you should see, if everything goes smoothly, is for each one of your FastQ files that you input, you should now have a fastqc.html file and then a fastqc.zip file. So you'll have 2 files for every 1 file that you input. And this HTML file is exactly that. It's an HTML file, so you can click it and that will open up a new tab in your browser or a new page in your browser. And this gives you your FastQC report. So this is the report that we're looking for each file. So for this particular FastQ file, here's the name of the file. And then it has some other information up here. Some key information are the total sequence reads that are in the file. So that's a very important metric that you need to know for all your sequencing experiments. So in this case, we have 22.2 million reads in this file. So there's quite a few sequencing reads in this FastQ file. You also get the sequence length. So you can see that we have about 250 base pairs. You also get this metric here, sequence is flagged as poor quality. So we didn't have any in this file. So that's great. So this basic statistics table, there's information here that's really helpful. Excuse me. The next metric down is kind of the canonical per base sequence quality plot that is also sort of a staple of determining the quality of your FastQ files. And this is a plot that has the Fred quality score on the y-axis, or I should say the average Fred quality score, and the base position of the read. And so let me just scroll back up so we can see the stats table and the per base sequence quality table plot. So what this plot is showing is for all 22.2 million sequencing reads in this file, This plot is giving us an average Fred score per base position of the entire 250 length of the read. And so you get this blue trace, which is giving us the average. And what's hard to see because this is such a high quality file is that these are box plots, and you're getting these scores that are giving us a metric of green, beige, and red. So below 20, a Fred score below 20 is considered low quality. That's below 99% probability of being correct. You have an intermediate range of 20 to 28, which is sort of acceptable, and a Fred score of above 28 is considered high quality. The next plot down is giving us quality in a little bit of a different view. Here we have the mean sequence quality score. The Fred score is now on the x-axis, and we have number of reads on the y. And so this view is kind of giving us the same information as up here, just in a different view. Here we're getting a distribution of how many reads, a distribution of the amount of reads per Fred score. And so what you could see here is ideally you want to have a distribution that is pushed way to the right, indicating high quality. And so you can see that we have the vast majority of our reads have a Fred score of over 30, which is very high quality. And then those are the three metrics: the basic stats table, the per base sequence quality plot, and the per sequence quality scores. Those are the main metrics that we really pay attention to. There are a bunch of other metrics down here that I'll say if you're interested in finding out more about those, I would recommend the video tutorial that the Abraham Bioinformatics Institute puts out. So hopefully this gave you a little bit of information about how to run FastQC in CyVerse Discovery Environment.